Okay, so I think the question that Sadie you were asking about on the homework for chapter 5, that was the double displacement reaction. Yeah?
Yeah, C.
Okay, so just real quick before we start into these, I just want to remind you guys that on a quiz or an exam, or we don't have a quiz for this chapter for chapter 5, but on an exam, I'm not going to ask you to go from the names to the chemical formulas for the balanced chemical equation. Okay, does that make sense? So that's for practice purposes because you are hopefully still learning your nomenclature, which is going to be on this exam, right? So it's to help you guys practice that, but on an exam, I'm not going to ask you guys to do both of those steps at once. Does that make sense? So don't stress out about that. That definitely makes this homework harder, right? But I'm just trying to keep you guys thinking nomenclature as we're going through and doing this balancing and chemical reactions. So also so we don't have the quiz for balancing chemical reaction types because we skipped that. We're doing the Lewis quiz this week, right? But the lab this week that we're starting is the balancing lab. Okay, so that one is available to you guys. It's going to be really helpful, I think. And it's also going to have a lot of similar questions to the way that you would see them on an exam. Does that make sense? So if you're wondering how those questions could look on an exam, that's a good indicator for you. Okay, so I believe the question you were looking at was 1C, is that right?
Yes.
And that was lithium sulfate plus sodium silver nitrate. Thank you. Oops. Silver. Okay, so lithium sulfate and silver nitrate. So this has two ionic compounds, right? Anytime you see two ionic compounds being reacted, that's going to be a double displacement, right? AKA double D. Okay. So whenever I'm starting with a double displacement reaction, the first thing I want to do is just write out the ions. So I'm just going to start out by writing the ions, and then I'll make the compounds, then I'll make the products, and then I can balance it. Okay, so it's a multi-step process here. Okay, so first things first, lithium ion is just going to be Li plus, right? Everybody's comfortable with how we found that?
Yep.
Cool. Sulfate is a polyatomic ion. What's that one going to be?
SO4 2 minus.
Yep. Right? Again, if you see an 8 or an ite at the end, that should be a cue that you have a polyatomic ion, right? If you still haven't gotten those memorized. Silver is going to be Ag plus. Recall, how do I know that? Because silver is one of those three that you can remember always stays the same. Silver is +1, zinc is +2, aluminum is +3, right? 1, 2, 3, up the stairs. And then what is nitrate?
NO3 minus.
NO3 minus, right? Everybody okay with me on that? So I want to stick these together to make ionic compounds. It's actually better if I'm down here. So if I'm trying to make a neutral ionic compound, right, which I always am, how many lithium do I need for every one sulfate? 2. Does everybody see that? Yeah? Okay. So I have lithium 2, right? The subscript is telling me how many lithium ions I have, and 1 sulfate, right? Now, just as a reminder, if you guys want to, you can put parentheses around this guy. You do not have to, but you can if it makes it easier for you to see. Question, Sadie?
So, yeah, so when you're writing this out, before you even start to balance it, you already put 2 with that lithium?
Yeah, because this is the compound, right? I have to start with the compound before I can ever do anything with balancing.
And then why do you get rid of the 2 minus?
The 2 minus is countered by the 2 plus charges from the lithium.
Okay.
Right? That's how these
show the lithium 2, but not that 2 minus if it's countering that one.
So when we have 2 lithium ions and one of these guys, right? Then here, let me draw it out for you.
Okay, I'm sorry.
No, that's okay. Right? So we have 2 lithium ions, right? Stuck to one of those guys, right? That makes us neutral.
Gotcha.
Right? And if you want to think about this in terms of the Lewis structure, right? If we had the sulfate polyatomic ion drawn out as a Lewis structure, right? We'd have 2 of those oxygens would have negative charges, right? That's where these lithiums would hook up to make it neutral.
Okay.
Right?
Yeah, that makes sense.
Yeah. So, but the chemical formula that we end up with for any ionic compound should always be charge neutral, meaning there's no more charges left, right? Everybody comfortable with that? Any questions? We're okie dokie. All right, and then for the silver nitrate, how many of each do we need?
Just 1? It's fine.
Yeah, just 1 and 1, right? So we'll have AgNO3. And I believe it tells you in the problem that they are aqueous, which is just telling you about the phase, right? Aqueous means that they're dissolved in water, okay? Everybody comfortable with how we got that? Cool. So the next thing that we need to do, we're actually given the products in this reaction, but when we get to chapter 9 into solutions, we're going to come back to these reactions. They're not going to feature too heavily on this exam because double displacements are reactions that happen in solutions. So we're just kind of introducing them here, and then we're going to get really into detail with them in chapter 9. But we know whenever we have an ionic compound hooking up with another ionic compound, that we always have cation, anion, right? Cation, anion, right? So what a double displacement looks like is these guys are going to change partners, right? But they can't just change partners any old way, right? We still have to have a positive and a negative charge, right, hooked up with each other. So what we're going to do is we're going to have this positive guy hook up with this negative guy, right? And this positive guy hook up with this negative guy, okay? Does that make sense? So that's what a double displacement is. Okay. So we have our reactants. And then we have our reaction arrow. And now we can start putting together our products, right? So if we have silver hooking up with sulfate, right? Because this is our positively charged guy over here and our negatively charged guy over here, right? How many silvers do I need for every sulfate?
2.
2. Is everybody comfortable with that? So I'm going to have a chemical formula, silver 2 sulfate. And I believe the problem tells you that this is a solid. And we have so we have lithium hooking up with nitrate, right? And lithium has a positive charge, nitrate has a negative charge. So how many of each do we need? 1 and 1, right? Is everybody comfortable with that?
Yes. Why is that now a solid?
You don't know about this yet. That's chapter 9. Yeah.
Gotcha.
Okay, so lithium nitrate is going to be our other product. Everybody okay with that? Cool. So now we have our chemical equation, right? It has reactants, a reaction arrow, and products, right? This one specifically, again, we're not changing the rules of how we put together compounds, right? So it's important to remember that we have a lot of ions in this reaction, right? But we have all of them in ionic compounds here, okay? Does that make sense? Ionic compounds, by definition, must be charge neutral, okay? Everybody with me on that? Cool. Can I erase this part down here? Cool. So now the next thing we want to do is we want to balance the chemical equation, right? So whenever we're trying to balance something, I think the easiest way to do that is to write all of the species that we have underneath the reaction arrow. Now with a double D, anytime you're dealing with polyatomic ions, it's easier to keep the polyatomic ions together than it is to break them up into their individual atoms, okay? So let me show you what that looks like. So we know we have lithium, we know we have silver, we know we have sulfate, and we know we have nitrate, okay? So what I mean is when we go from one side of the reaction arrow to the other, sulfate and nitrate are not breaking down in this type of reaction, okay? They're always staying as sulfate and nitrate, okay? Does that make sense, guys? Cool. So we have 2 lithiums over here, right? And 1 lithium over here, right? So if we know we have 2 lithiums over here and 1 lithium over here, what are we thinking we're going to need to do to this side of the equation to make it balanced? Yeah, we're going to need a 2 in front of this guy, right? Uh-oh. Cool. Does it make sense why I put a 2 in front of the lithium nitrate? Is everybody comfortable with that? So if we have 1 lithium, right, we can't just add another lithium ion, right? We have to add a whole lithium nitrate to this side, right? So we're only changing the number of each compound, not the ion. Okay? One question? Are we okay? Okay, cool. All right, so then silver over here, we have one of these guys and two of these guys, right? So what do we think we're gonna need?
The two in front of the reactant.
Yes.
Silver.
So in front of silver nitrate, we're gonna need a 2, right? Everybody okay with that? So that'll give me 2 silver and 2 silver. Over here, I have 1 sulfate ion, right? Over here, I have 1 sulfate ion, right? Over here, I have, so the 2 out front here applies to the silver, but it also applies to the nitrate, right? So we have 2 silver ions, but we also have 2 nitrate ions. Everybody comfortable with that? Cool. The same thing goes for over here. So we have 2 lithium ions, but we also have 2 nitrate ions, right? So we balanced?
Yeah.
Yep. So the whole name of the game with balancing equations is we want to make sure that we have the same number of atoms on the reactant side as we do on the product side, right? And the point of that is that we are not doing magic with chemical reactions, right? We're doing chemistry, and chemistry requires that we don't make something out of nothing, right? So we can't make matter out of thin air. We can't have magically new atoms appearing on one side of the reaction. Any other questions about how we did this? So your balanced chemical equation would look like this, okay?